Hello Ace, this is RetroTK2 and today we're learning the basics of inheritance in C#. If this is your first C# video, I'd strongly suggest watching the series from the start. The card should be on your screen now. And if you haven't already, might I suggest downloading the channel files that accompany this video. The card should be on your screen once again. So let's get started. What is inheritance? According to the Microsoft Docs, inheritance is a feature of object-oriented programming languages that allow you to define the base class that provides specific functionality, data and behavior, and to define derived classes that either inherit or override that functionality. Inheritance is one of the fundamental attributes of object-oriented programming. It allows you to define a child class that reuses, inherits, extends, or modifies the behavior of a parent class. The class whose members are inherited is called the base class. The class that inherits the members of the base class is called the derived class. C# and .NET support single inheritance only. That is, a class can only inherit from a single class. However, inheritance is transitive, which allows you to define an inheritance hierarchy for a set of types. In other words, type D can inherit from type C, which inherits from type B, which inherits from the base type A. Because inheritance is transitive, the members of type A are available to type D. Not all members of a base class are inherited by derived classes. These are static constructors, which initialize the static data of a class, instance constructors, which you call to create a new instance of the class. Each class must define its own constructors, and finalizers, which are called by the runtime's garbage collector to destroy instances of a class. Finalizers are also known as destructors Ace, but we'll talk about them in the far-off future. All other members of a base class are inherited by derived classes. Whether they are visible or not depends on their accessibility. A member's accessibility affects its visibility for derived classes. We've already seen all about the accessibility modifiers in early videos Ace, so this should seem like expected behavior. Private members are visible only in derived classes that are nested in their base class. Otherwise, they are not visible in derived classes. Protected members are visible only in derived classes. Internal members are visible only in derived classes that are located in the same assembly as the base class. They are not visible in derived classes located in a different assembly from the base class. Again, yes, we'll talk about assemblies at some point in the distant future. Public members are visible in derived classes and are part of the derived class public interface. Public inherited members can be called just as if they were defined in the derived class. Inheritance is a pretty big beast Ace, and we won't be covering all of it in this video, but we are at a pretty good place to start. Open up Unity and create a basic C# script. As always, make sure you give your script a different name than any other class in your project. I'll also be using Unity Spice for all our logouts here Ace. If you would like to get it for free, click the card on your screen now, or you can just follow the link in the description. Here I'm going to create two classes, A and B. Now I'm going to make class B inherit from class A. To do that, we place a colon after the class's name. Next, we type out the class that we want to inherit from, which is A in this case. Class B now inherits all the members of class A Ace. If we define a public method in class A and create an instance of class B, we can now call that method from our instance of class B. If we save, head back into Unity, drag our script onto any game object in our scene, and run the game, you'll see that method A is logged. Now, as the doc said, private members are visible only in derived classes. So if we declare a public field in class A, you'll see that we can't access it publicly from our instance B. No surprise there Ace. And we also can't access it in a declared method in our class B derived class. Again, no surprise there Ace. However, we can access a protected member in our inherited class. If we declare a protected field, you'll see we can't access it publicly with our class B instance. But we can access it in our derived class's declared method. Very useful Ace, and we can do this with other methods and properties too. We can also declare another class Ace and inherit from our class B. So now class C will inherit the members of class B, and it will also inherit the members of class A as well. This is probably fairly obvious by now Ace, and if you get a good handle on this inheritance stuff, object-oriented programming becomes a lot easier. Constructors are pretty tricky too with inheritance Ace. Here I'm creating a constructor in our class A with an int as a parameter. Doing this will cause an error. base class A doesn't contain parameterless constructor. If you have ReSharper, you can instantly fix this by clicking on the class keyword, pressing Alt and Enter, selecting Implement Missing Members and press Enter. You'll see that it will add a constructor for class B, but it will also call the base constructor of class A. Here I'm also going to repeat this step for the same error we're getting on class C. The syntax of this may seem a bit strange, yes? I know I thought it was the first time I seen it, but all it's doing is calling the base constructor first, and then it'll execute this constructor's code afterwards. If we save, head back into Unity, and rerun the game, you'll see that constructor A is logged first, and then constructor B. Awesome. A word of warning though, Ace. This inheritance stuff is great, but it can get out of hand very quickly. In my experience, it's best to keep the inheritance very shallow, so really only about 1 or 2 levels deep. However, you can then have many classes inherit from the same base class. The reason for doing this is because of a phenomenon known as coupling. Having deep inheritance gives a class very tight coupling. But we'll get into this discussion whenever we finally start developing Ace. Still, it's good to be aware of this kind of thing when you're starting off. This has been a basic introduction to inheritance in C#. And that's it. Rate, comment, and subscribe, Ace. I hope you're enjoying this series. You can email me at retrotk2@gmail.com with your inheritance. Thank you for watching, Ace, and I'll see you in the next video.